Hi viewers, dear students. I am going to discuss today the infinite series, which is the continuation of the previous classes to give previous classes. Today I take up two theorems of infinite series. First is Cauchy root test. Its statement is, if un greater than 0 be an infinite series of positive terms and un to the power 1 by n tends to L infinite number, then sigma un is convergent if L is less than 1 and divergent if L is greater than 1 and equal to 1 in the case test fails. We take case 1 when L is less than 1. Now, as given, un to the power 1 tends to L, it means that L minus epsilon less than un to the power n less than L plus epsilon. When L less than 1, we take un to the power 1 by n less than L plus epsilon. It means un less than L plus epsilon to the power n. It means u1 is less than L plus epsilon, u2 is less than L plus epsilon square, u3 less than L plus epsilon cube, and so on. Now we take sigma un, that is equal to u1 plus u2 plus u3 plus un plus so on. Now we see that u1 is less than L plus epsilon, u2 is L plus epsilon square, and so on. Then u1 plus u2 plus u3 so on is less than L plus epsilon square plus L plus epsilon cube, and so on. We see that the series on RHS is a geometric series whose common ratio is L plus epsilon and L is less than 1. That's why L plus epsilon is also less than 1 as epsilon tends to 0. We see that the series on RHS is a geometric series whose geometric series is a common ratio is L plus epsilon less than 1. So this geometric series is convergent, and the left hand series sigma un is a lesser series, so it is also convergent. Now we take case 2 when L is greater than 1. We take the case when un to the power 1 by n is greater than L minus epsilon. It means that un greater than L plus epsilon to the power n. It means that u1 greater than L plus epsilon, u2 greater than L plus epsilon square, and so on. Now we take sigma un is equal to u1 plus u2 plus u3 plus so on. And it will be greater than L plus minus epsilon plus L minus epsilon square, and so on. We see that the series on RHS is a geometric series whose common ratio is L minus epsilon, L is greater than 1, so the series on RHS is divergent, and in this case sigma un is greater than series, so it will be also divergent. Now we finish Cauchy root test. Now we come on the second important theorem, which is likely to be comparison test. It is quietly different. Its statement is, if sigma un and sigma vn be two infinite series of positive terms and sigma vn is given known series, it will be either convergent or divergent, having two different cases. Now we take if sigma vn is given to be convergent and first un by un plus 1 greater than vn by vn plus 1, then sigma un will also be convergent. And if sigma vn is given to be divergent and the case is un by un plus 1 is less than vn by vn plus 1, then sigma un will also be divergent. We take first case when sigma vn is given to be convergent and the condition un by un plus 1 greater than vn by vn plus 1 is applied. It means that if we reverse the system, that is un plus 1 by un is less than vn plus 1 by vn. It means that u2 by u1 less than v2 by v1, u3 by u2 is less than v3 by v2, and so on. Now we take sigma un. Sigma un is equal to u1 plus u2 plus u3 plus so on. If we common u1, it will be 1 plus u2 by u1, 1 plus u3 by u1 plus so on. And we proceed u1 common 1 plus u2 by u1 plus u3 by u2 into u2 by u1 and so on, and it will be less than u1 plus 1 plus v2 by v1 plus v3 by v1 and so on, and finally u1 v1 1 plus v1 plus v2 plus v3 plus so on, and it will be equal to u1 into v1 into sigma vn, and sigma vn is given to be convergent, and the lesser series sigma un is also convergent. Now we take case 2 when sigma vn is given to be divergent and the condition is un by un plus 1 is less than vn by vn plus 1. If we reverse the condition, that is un plus 1 by un greater than vn plus 1 by vn, in the same case u2 by u1 greater than v2 by v1 and so on, and in the similar case we take that sigma un is equal to u1 v1, sigma un will be greater than u1 v1 into sigma vn, and sigma vn is given to be divergent, so the greater series sigma un will also be divergent. These two theorems I have given in PDF. Our students can easily understand this theorem easily, and today's lecture is finished. Thank you.